Doing something to test the input. Testing. Can you hear me? Weirdly choppy. Okay. Hmm. It's, oops, it's not in there.
Up with. So I'll just give you an introduction to DataDrive2030. We are a newly established social enterprise. We started last year, but a lot of our work has started way before, in the early 2000s to late 2000s. We focus on democratizing early years data. And so we aim to make this childhood data accessible to everybody who needs it, easily understandable, so anyone can understand it without any training in data science specifically, and most importantly, actionable. And we want this to lead to tangible change in young child outcomes. So we believe that data tools and insights are key to closing this opportunity gap. And then I'll share a little bit on these gaps, particularly in a South African setting. So we did a really large study of over 5,000 children, and we found that less than half of children who attend an early learning program, such as a preschool or creche in South Africa, start school with the right foundations in place. So that means more than 50% are not on track for the development. And if we further disaggregate this into socioeconomic outcomes, we see that the outcomes are more dire for poorer children, where only 3 out of 10 of children in the poorest, attending the poorest ELP start school on track, versus 8 out of 10 in the richest households. So we really exist to decrease these two gaps in particular. So here are our goals. So using these tools and this data and your analyses among one of them, we hope to increase the percentage of children in South Africa who thrive by 5, setting them up for long-term success. It's about your life trajectory. And then we hope to decrease the performance gap between the young children in the poorest and richest households when they enter school, so preschool or creche. So we do this by managing and making available a suite of tools. At the moment, we have 6 tools, and here they are. So the first 3 at the top are direct child assessments. So the data we have in the challenge relates to this this assessment, which is the 4 and 5 years assessment. And that's a direct child tool. That's your target variable. So the total score for that tool is the target variable in the competition. We also have a targeting tool, which is a shorter version, and then a 6 and 7 years tool. And then 3 at the bottom are not direct child assessments, but the socio-emotional functioning. We ask a teacher to rate the child's functioning. And then the other 2 are about the quality of the program or the home environment. So we'll focus on the 4 and 5. The data that you have is a collation of all the organizations and research studies that have used this tool. So it's 12,000, we're looking at more than 12,000 children. And then this is a breakdown of the kind of variables that we have within this data set. So we have fee level information for about 8,000 that will tell you whether a child is coming from a poorer or a wealthier early learning program. We have some for socio-emotional functioning, so that would be able to tell you whether the child is meeting their emotional readiness or their social skills. Are they able to manage their emotions well or play well with other children? And that's teacher rated. We also have about 2,000 for observations within this data set telling you about the early learning program. And these are specific questions around teaching strategies, the environment, the resources. And then home data is really, really hard to come by in the setting. And so we only have observations of the home learning environment for around 275 children. And then we also have their malnutrition data. So are they at risk for stunting or malnutrition? That's about 9,000 children. And then we have more information on the principal or through a principal interview or information on the facility as well. So environmental characteristics like books as well, resources as well, on around 7,000. So there's a lot of overlap between the learning program quality and then additional observational data. So it's really, this is also the richest data set we've ever had on early learning outcomes in the South African setting in particular. So it's really exciting that you're among the first to really delve and deep into these data. So really what we want to do is to build a model that will help us to predict which factors contribute to child outcomes. So your target variable, which I think Darius will talk more about, is your total ELOM score. And then there's all the other variables. We'd like to know which of these best predict that child outcome or that total ELOM score. And then the reason for this is because we want to understand how best to allocate these resources, especially in scarce resource settings like your poorer ELPs. And so using your predictors from the challenge, we would then see if we could design interventions to better allocate these resources in these settings. So it's really all about, this is our bell curve, and how do we shift this bell curve by 2030 so that more children are starting school on track for their development. Yeah, and that's it from me. But looking forward to your questions and really looking forward to your answers on the challenge. Thanks, Paul.
Fantastic. Thanks, Janita. I'm just fixing my spotlight here. There we go. Thank you so much, Janita. Maybe you can answer one or two of my questions straight off the bat. Have you done as DataDrive2030, have you done much in the way of machine learning or modeling on other projects or on this data?
We have. So we have a project called the Positive Deviance Initiative, and we partnered with Data Explore Academy, which is a data science academy, and they have done some preliminary machine learning. Their students have investigated the data in some preliminary ways, but we really wanted to expand it and make it just broader and more accessible to non-traditional people in early learning program, which are your data scientists and machine learning experts.
Fantastic. And while I'm talking to Janita, please do feel free to raise your hands if you'd like to ask her any questions right now, or even type the questions into the chat and we'll get them answered. The other question I wanted to ask was, what do you, I guess, what do you hope to get out of this, this collaboration, this partnership? What do you, what in a perfect world, what do you see happening with these models and these tools that we develop?
Yeah, so I think on the one side, we really want to increase the access to everybody of the data. And I think we really want to promote the use of this data amongst data scientists, so that we would really like to see a community of data scientists coming to early learning and using this data. Secondly, we really want to see what kind of factors are predicting these outcomes. It's coming from a non-traditional lens, we might identify factors that literature or that early childhood experts may not have identified. So we really want to remain open in this process to any factor that is contributing to improving child outcomes. And then as a result of that, design interventions that can improve our resource allocation to target these variables, or to see how we can change variables and manipulate things within settings to improve and shift that bell curve.
Yeah, I think your second point around innovative ideas is something that we've seen time and again that the Zindi community is really good at. Our clients and our partners often come back to us and say, well, we just never, that's an approach we never even thought of. We never saw this coming. So I think that's one of the real powers of what we're doing here, which is really exciting. And I hope it works out.
Thank you. I hope so too. And then also, Paul, just to say, we also have geolocated data on our data set. So if participants want to merge in secondary data sets, they are by all means welcome to do so, because it could be that there are things we don't think about in our data collection process that might make a difference or that might be contributing to outcomes.
Fantastic. Great. And there's, I guess, a bit of a curveball, a bit of something a bit unusual about this challenge in terms of the pipeline that you're asking participants to produce. But I think we'll hear from Darius a little bit more about that. And if people have more questions, then maybe you can chip in on that as well later on.
Absolutely.
Fantastic. Thank you. Thank you so much, Janita. Really appreciate your time and your contributions. Please do feel free to ask some questions if you'd like. Other than that, I'm going to carry on and invite Darius to join us for a walkthrough of the starter note. Darius, are you with us?
Yes, I am, Paul. Thank you.
Fantastic. Please feel free to share your screen.
Sure. A minute. I hope you can see my screen.
I can see your screen. Sure, you can go ahead.
Thank you, Paul. So my name's Darius Mururi. I'm also from Zindi. I'm a data scientist. I'm based in Nairobi, Kenya. So I've prepared a short note, starter notebook for the challenge. I'll be taking you through it. But before we go there, this is the Zindi platform. If you want to check out the competition, maybe I can share a link also in the chats. So this is the challenge. It has a prize pool of 3,000. The first place will get $1,500. The second place 900. Third place 600. So the main objective of this competition, as Janita Soldier said, is using machine learning techniques to identify which are learning program factors contribute to better learning outcomes in children. So you are given data with the ELOM score as the target, and then your main objective as a data scientist or a data analyst is to come up with which features influence more the target. The evaluation for this challenge will be the root mean squared error. So this is how it will look like. I'll be taking through the starter notebook in a minute. And then at the end of the competition, when you're submitting your solutions, for you to qualify for prizes, the top 10 will also need to submit a sensitivity analysis pipeline where you input your variables through a pipeline, do the pre-processing, do the machine learning or deep learning, and then output the top 15 variables that influence the target or the ELOM score moving from maybe yellow to green. So you can go through this section of the competition and get familiar with it. So I can move on to the starter notebook. So the starter notebook is just to guide you on how to build a machine learning model. It's very simple. So you're supposed to create a more complex one in a way that performs better than this one. So I'll be using Python as my programming language. You're free to use R. And then when it comes to the libraries for Python or R, make sure that you use only open source libraries. That's just to keep things fair across the platform. You have been provided with some data for training and test. Maybe you can check here. So once you join this competition, you can come down here and then you can download all this data for your use. Also, the starter notebook is here with other files. So the main focus of this challenge, as it is a machine learning challenge, the focus is on finding which variables influence the target. So the first thing is you're supposed to build a good model that can predict the ELOM score. And then after that, find out which top variables influence the target. So some of the libraries we'll be using, for me, I'll be using the LE5. You're free to use another model interpretability library like Sharp or Lime. And then for data manipulation, I'll be using the pandas library together with NumPy. And then for modeling, I'll be using the sklearn library. So these are some of the files that we use to train a model. We are provided with the training file, the test, and then a sample submission. So if we look at the train data set, this is how it looks like. We have the child ID, data here, and some other variables. And then you also have the target. So this is the dependent variable. And then these are the independent variables. So you're supposed to use these variables from child ID up to OBS hitting 7 to try and predict the target. The test is similar to the training file, but the only difference is that you are not given the target. That's what you are supposed to make your prediction on. So if we look at the number of columns in the training data set, we can see that there are like 679 columns, but the test has 678, with the only difference being the target. We can move down and preview the sample submission file. So once you have created your machine learning model or deep learning model, this is how you are supposed to prepare your submission file, the one which will upload to Zindi for scoring. So for each child in the test set, you are supposed to predict the target and then also provide the top 15 variables that affect the target, like in terms of weight. How important is feature one in influencing the target? Yeah. And then for a simple model, we have a target variable, which is the y variable here. And then because this is just a simple model, we can use only the numerical columns. So a subset of numerical columns here. And because we are using linear regression model from the sklearn library, it's recommended that you fill in the missing values. So for me, I fill the missing value to 0, but you're not restricted to filling 0. You can experiment with filling the mean, maybe a large number, or do some research on the best techniques on filling missing values. And then it's also a good thing to split your data into training, test, and validation. So I did the same here just to check how good this model performs locally. So by training this linear regression model, we can see that I got a mean squared error of 11. This means that my predictions are off by plus minus 11. So you're supposed to improve this. So far in the leaderboard, we check the first person has like 9.45. So I think you're supposed to beat that in case you want to win some prizes. So into the most important part that you are more interested in is the top features that influence the ELOM score. So from the linear regression model that we built, we can see that the OBS lighting 3, it has more weight in terms of predicting the target. So if you don't know what OBS lighting 3 means, we have a variable definition file that you can download also and take a look. I think it's somewhere here, this one. It will give you in more detail on what OBS lighting 3 is and other variables. So we can continue and take one sample, like let's see one child. We make a prediction. What are maybe the top 5 features or variables that affect the ELOM score? So select one sample from our X test, or from the X train, I mean, and then we can check out the top 5 features. From our model, you can see that the year has quite a lot of significance when it comes to predicting the target as the ELOM score. Also the child age and the teacher emotional total, plus the language match. So these are some of the features that highly influence the target. I think this is quite good because the data has a lot of variables. You can't focus on all of them. We are supposed to just reduce them to the most important features that influence the target. You can do the same for the top 15. Here I did for 5. You can do the same for top 15 and then change this graph to a pandas data frame. So it's more clearer. You can see that data here, child age, child observed total, all these variables. These are the top 15. So after doing that, now I think you are ready to make a prediction on the test set that is provided. So we use the model we trained to make the predictions. So usually whatever you do in the training data set, you're also supposed to do it in the test set. So in the training data set, we filled the missing values with 0. So we have to do the same with the test set in this case. And you can see here. And then for each prediction, we have also to extract the top 15 features from each sample. So I used a for loop here to get those. This is just a preview of the sample submission file. It should guide you on how to create your sub file also to upload to Zindi for scoring. So this is submission file preparation. We can see here, if we look at the submission file, this child ID, we have predicted that we have an LM score of 52. And then the most important feature is the data here, the second being child age, third, fourth, up to 15. Yeah, so once you have done that, you can download your predictions file. And then once you have done that, you can come to the competition and make a submission for you to get a score and a ranking. These are some of the libraries that you can use for model interpretability, or if you want to extract the top 15 features from the model. You can use Sharp, Lime, Yellow Brick, Lucid, or do some research and see which library fits your case. But make sure that the library is open source and is available to everyone. Yeah, I think that's it from me. I don't know if there are any questions.
Thank you so much, Darius. If there are questions, now is the time. We have access to somebody from DataDrive2030 as well as our very own guru, Darius Maruri. So please do ask your questions. If you don't have any questions, or if you're too shy, you can always pop your question on the leaderboard or send a private message. And we're very happy to help out in any way that you need. Thank you, Janita, for sharing your contact details as well. I appreciate that. There was one question that I had, and now I'm trying to remember what it was. Yeah, I think I'd like to ask if there aren't any other questions from the floor. Darius, I'd like to ask a little bit more about and maybe this is for Janita to answer. I'm not totally sure. Like to ask more about the data pipeline that we talked about as something that we're requesting from the top 10. You touched on it briefly at the beginning of your presentation today, but maybe you could go into what we're expecting in a little bit more detail on that subject.
Sure.
I hope I'm not putting
I
you on the
can
spot,
talk.
but just a little bit of an explanation to help people to understand what they'll be trying to achieve beyond just building a machine learning model.
Yeah. So usually, when you are in the top 10 in the leaderboard, you are supposed to send your code to us for review. The code usually includes only the machine learning part. But for this challenge, we are more focused on the sensitivity analysis report. So we have cutoff points for the target. The target is the ELOM score. So let me just show you here. So you're supposed to use the child age and the target for you to get the category of that child. So for example, this child here is 59 months, I guess, and then the target is 51. So 50 to 59 months, and then the ELOM score is above 46%. So this child, good thing is he or she is in the green category. But if we assume that this child was in the yellow category, so the sensitivity analysis report is supposed to help us to know which variables we should increase or reduce to move this child from being yellow, that's falling behind, to move the child to the green zone, which is achieving the standard. So the pipeline should be, given all the variables that you have provided with you with, put them through a machine learning model or some pre-processing of some kind. And then for each child, provide the top 15 variables. Is the top 15 variables, the current value, and then you're supposed to do a sensitivity analysis calculation to know by how much you should move that variable so that you move that child from maybe red to yellow or from yellow to green. So this report is expected after the end of the competition, after we have got the top 10 solutions. If you have any questions, I think you can post them on the discussion board, or you can ask one of us at Zindi, and then we'll be able to answer you.
Okay, thank you so much, Darius. I think that is a lot clearer, at least to me now. Appreciate that. We have one question from the audience. I hope I get the name correct, from Andrzej Sheltsev. The question from Andrzej is, the final leaderboard uses the test data, which is fully available to the participants. Can the test data be used for pre-processing, e.g. by standardizing the data using statistics from brain tests? Are you able to answer that one, Darius?
So the data is fully available.
Mhm. Hi, Darius. I think we've lost your audio. Are you able to hear us? Oh, it looks like maybe Darius is disconnected and reconnected. Darius, are you there?
Yeah, sorry.
Yeah, we lost you right at the beginning as you started giving your reply. Maybe you can just start again, please.
Sure. Let me share my screen again. You can see my screen?
Yes, we can.
Thank you. So I was saying that the training dataset and test are available to everyone, but only Zindi has the target variable for the test. I was looking at the number of columns in the train, like we have 679 columns in the training dataset, but in the test, we have 678. You don't have the target in the test. This is what we have, and this is what we'll be using in our backend to for scoring and ranking. Also, when it comes to feature engineering or creating new features, yes, you can use the target variable here in the test, and then emulate the same in the test set. So that's allowed. I hope I've answered the question. Maybe if you need more clarification.
Yeah, can you hear me?
Yes, I can hear you.
All right. The question was whether we can use the test features, not the target, but the test features for preprocessing, for instance, when standardizing numerical features.
Yes, you can.
All right, perfect.
Cool.
Great. Okay. Are there any other questions before we wrap up for the day?
I have another question.
Right.
Okay. The question would be, if we do feature engineering, do the engineered features have to have an humanly interpretable meaning, or can this be also through a function, through an arbitrary function, as long as the function is made available and can be interpreted as well?
So this competition is more focused on model interpretability. So we prefer that the features created make sense, like not like a feature that you can explain that I did this and this and this to this feature, and then it improved the model by this margin.
All right. So they have to be interpretable. Thank you.
Yeah.
See something from Iman saying the pre-processing must be the same for both train and test sets. I assume that is a question, and I think the answer is yes. Darius?
Yes, that's correct. So whatever you do in the training data set, you have to do the same to the test set. So if the number of features in the training data set is 100, the test set also has to have 100 features. So that's a yes.
A question from Julius Miner. What happens if some people cheat in inverted commas in the competition like they did in user engagement? I will answer that because I know the answer very clearly. Cindy has a policy of the models being valuable or usable. If a model is cheating in the way that you're talking about, in a sense of using features that aren't relevant or real to the final outcome, so therefore artificially improving the score without effectively improving the score, Cindy will disqualify those submissions. We retain the right to disqualify any submission that is not essentially not solving the problem that the competition sets out to solve. I hope that is clear. Suggestions for free GPU training, except for Kaggle or Colab. The question is coming from Johnson Damini. Darius, I'll leave that to you to answer. I think I know there are a number of GPU cloud notebooks out there. Do you have any suggestions of any that people could use?
Yeah, so for free, mostly I use Colab, but the other ones you have to pay for, like the cloud services. Plus, this data set is quite small. It's not that large. I don't think you need a lot of GPU resources for training. You can use Colab. Colab just needs you to have a Gmail account, and then you are good to go.
Look, I know there are also, I think if you just do a Google, there are a lot of articles out there touching on the options that are available. I have a question here from Reynard Rianda. If we use feature engineering, does it also count as features eligible for the top 15, for the 15 top predictors?
So long as they are interpretable, so long as you can make sense of them.
I think that's straightforward. So as long as the features are interpretable, you can use them for the top 15 predictors as well. Great.
Paul, sorry, can I just add on the interpretability? So I think when we're thinking about the features, we really have in mind that, this is about allocation of resources. Think about your preschool or creche experience, what can change tangibly in that environment, in an intervention, or, something policy-wise, something practical. And it's by no means limited to my view of practical or somebody else's view of practical. Like, if it makes sense to you and you can motivate, or you can see how this can influence a child's outcome practically, then please think about it like that. It has to, I don't know if that's helpful, but think about the end goal or our larger objective being tangibly moving a child from the yellow to the green, or the red to the orange.
Yeah, I think that's a really great point, and something we encourage our users to think of all the time in Zindi competitions is we're not just trying to maximize a score. Like, anybody can, not anybody, not to belittle the work that goes into getting to the top of a Zindi leaderboard, but there's more to a Zindi competition than having the most accurate model possible based on the data. And I think it's a really important point. Actually, that reminded me, Janita, of the question I wanted to ask earlier, which was, and this could be for Darius or Janita to answer, how much does domain knowledge matter in a competition like this? For somebody who doesn't know anything about early childhood development or about learning programs, how much does understanding the work that you're doing, understanding that sector, how much does that play a role in the quality of the models that people are going to be building?
It's a great question, and I think it's a question we struggle with as well, because you don't want someone with too much domain knowledge that's coming in with kind of like a narrow mind and heavily influenced by the literature or what they know. But so we're very, very open to innovative ideas, as you said earlier, and if it makes sense to you, then very happy to look at it and to consider how it can be interpreted into the setting. So domain knowledge can to some extent play a role, but don't let that limit you in any way or form. If it makes sense, if it's something that you can see tangibly, or something that you can logically process to influence an outcome, then please. And if you're finding something strange and you want help to figure it out, or you're struggling with interpretability, we are here. We can connect you to external people. If you'd like to discuss it, you can discuss. Please reach out and I can connect you with somebody.
Fantastic. That's really great. Thank you, Janita. I see one other question from Andrew. Can the solution be published in scientific conferences or journals after the competition ends? I think I'll answer from Zindi's perspective, which is that we're always interested in impact and seeing the work go beyond the end of the competition. So that's something that certainly Zindi would be open to. And we've done it in the past, especially with winning models where Zindi, the partner or the client, and the winning data scientists collectively write a paper and publish it. It has happened in the past. Janita, does DataDrive 2030 particularly have plans in that regard?
Yes, so I was just typing a response, but we would
Brilliant.
definitely be sharing, if depending on the outcomes and what we find, we would definitely love to share the winners' findings. We also have a network of academics, so there's definitely opportunities to publish if you would like. Yeah, there's definitely sharing and opportunities forthcoming.
That's really cool to hear. I think my background is research communication and impact of research. So that makes me very happy to know that we might be able to get an awesome case study, get a paper published, and really have an impact on the global conversation around ECD and these learning programs.
And on the other hand, Paul, we always focus on our research community and the policy community, but at DataDrive, we also focus on trying to make this data accessible, or our findings accessible, to actual practitioners on the ground or people at the grassroots level. So while there are opportunities for research papers, for more technical audiences, I think it's more difficult to make your finding more digestible to a larger or broader audience sometimes. And there's also opportunities for that. So there's lots of opportunities for sharing to different audiences and in different forms if others are not feeling the research community as well.
Amazing. And do you guys maintain a GitHub or a data repository somewhere that people can contribute to or fork from, etc.?
Sorry, Paul, I didn't hear the first part.
Oh, sorry, my connection's a little bit unstable. I was asking if you maintain a GitHub directory or a similar repository that people can contribute to.
We don't at the moment, but yeah, that's definitely something we can consider. We do keep our data on Data First as well. So our data is open access. This data is not open access yet, but post the competition it will be, and we'll continue to add data there.
Brilliant. I do also see a question in the chat. Is the competition prize available to people worldwide? And the simple answer is yes, this is open to everybody. Okay, we have 5 minutes till the official wrap-up time. There's certainly time for 1 or 2 last questions if anybody else wants to ask anything, or any contributions or suggestions even. I'll give one last call for any comments. Okay, looks like nothing. As we've mentioned before, please do feel free to ask questions in the chat, or rather in the discussion forums of the competition. You feel free to reach out to Darius or Janita or myself if you have any particular questions. I see there's a question about the recording. We usually upload recordings of these webinars within a day or 2 after the webinar, so please just give us a little bit of time, but it'll be uploaded onto YouTube. We usually also share the recordings out via the Eventbrite sign up list, so they'll be in your inboxes shortly. Thank you everybody for showing up today and for leading what I found a very interesting conversation. Thank you particularly to Janita for giving us your time and your expertise. Thank you to Darius, as always, for running a great starter notebook. And I hope you all have a very good evening further. Let's leave it at that. Cheers, everybody.
Thanks, Paul. Bye.
Thanks, guys.
You.